Sunny skies and calm weather have a way of making the mountains feel quiet, almost like nothing is happening. It's easy to assume the snowpack is gaining strength and becoming more stable. But in Utah, some of our most dangerous weak layers don't form during storms. They form during calm, clear stretches right at the snow surface. I'd say this is our weakest snow right there. There are three common types of weak surface snow that develop in cold, clear, and low wind conditions: near-surface facets, radiation recrystallized facets, and surface hoar. On their own, these layers aren't an avalanche problem. The concern comes later, when they get buried by new snow and become persistent weak layers. Near-surface facets form when strong temperature swings drive vapor through the snow near the surface. Warm days and cold nights slowly transform rounded grains into weak angular crystals that bond poorly. Many riders call this recycled powder, and it can provide great riding conditions. Sun, wind, or dense surface snow can destroy them, which makes them tricky. Once buried, near-surface facets can be hard to identify and can allow even thin slabs to propagate surprisingly far. Radiation recrystallization is another way facets form, most often on solar aspects. It happens when cold air temperatures combine with enough sun to lightly melt a thin layer below the surface, which then refreezes in the shade. This creates a thin sun crust with weak faceted snow on top. Once buried, that crust can preserve the weak layer and act as a slick bed surface. Then there's surface hoar, the classic persistent weak layer. Those sparkly feather-like crystals standing upright on the snow surface form during calm, clear nights when moisture deposits directly onto the snow. Surface hoar is beautiful, fragile, and notorious. Once buried, it fractures easily and can propagate across large areas, producing dangerous avalanches days or even weeks later. The real shift happens when weak snow gets buried under a slab. Slabs concentrate stress and allow fractures to travel. In Utah, avalanches failing on persistent weak layers account for the majority of avalanche fatalities. The challenge is that these problems don't always come with obvious warning signs. Things can feel quiet, right up until they're not. The takeaway is simple. Calm weather can quietly set the stage for future avalanche problems. Paying attention to surface conditions helps explain why forecasters often grow cautious before storms arrive. Weak snow doesn't need much, just the right slab to become dangerous. When snowfall returns, it's time to dial things back, choose terrain carefully, and remember that a lack of recent avalanches doesn't mean the problem isn't there.